Okay, so here's problem number 3. Problem number 3 starts off like this. Y equals x squared plus 3x plus 7 all over x plus 2. Can you look? This is a lot like the first one that we just did. The numerator has a power of 2 and the denominator has a power of 1. So we're going to have another linear oblique asymptote again. If you divide this out, okay, and I'll spare you the details. If you divide it out, you'll get x plus 1 plus 5 over x plus 2. There's your linear part. Here's the part that messes things up when you get around negative 2. X equals negative 2. So we're going to have an oblique asymptote at x plus 1. So it's going to look like that. This is 1, that's negative 1. Okay, and then we're also going to have a vertical asymptote at negative 2. So there's negative 2, like that. Okay, so now we just got to figure out where the min and the max are. So we can do that with y prime equals 1 plus low d high minus high d low over low low. And I use this one to do the derivative, not that one. Equals 1 plus negative 5 over x plus 2 squared. When does that equal 0? That happens when 1 equals 5 over x plus 2 squared. X plus 2 squared equals 5. And so x plus 2 equals plus or minus square root of 5. And finally x equals negative 2 plus or minus square root of 5. Okay, so square root of 5 is about 2.2. So if you look at the plus side of this, negative 2 plus 2.2 is just barely positive. So we're going to have a minimum probably right here or right here, and we've got to figure this out. So we'll just hold off on that for a sec. I'll just put that right there to remind us. Negative 2 minus 2.2 is about negative 4.2. So we're going to have another critical value right around here someplace. So that's about negative 4.2. This is about positive 0.2. Okay, so now we just need to figure out which side of the asymptote we're on when we're to the right of negative 2 and to the left of negative 2. Take a look at to the right of negative 2. If you're to the right of negative 2, this denominator is positive, which means we're going to do x plus 1 plus a little positive number, which is going to put our minimum right here. And then this side's going to end up looking like that. And that's our minimum. Okay, now, if you're to the left of negative 2, let's see, that's going to make this number a little greater than or less than negative 2, which will make your denominator negative. So we're going to do x plus 1 on the line, then subtract a little bit. So this side is going to look like that. And then it's going to come down like this. And that's going to be our maximum. That's basically what it's going to look like. And you can find these points by plugging in your critical value back into the function, but I really don't want to do that, so I'm not going to. This is good enough to know where it's going to, what it's going to look like. And in fact, I have a graph where I graphed it, and you can see that's exactly what it looks like. So you've got your asymptote here at negative 2. There's your minimum just to the right of the y-axis. There's your maximum right here, just right about negative 4 or so. So it works.